Today, we're going to cover the following topics. We're going to cover the number system, exponents, number patterns, equations and inequalities, as well as functions and graphs. I've put a bit of information in this presentation that will help us when it comes to solving the questions. For now, we just have the number system, how numbers are classified. I'm sure this rings a bell to all of us here. And hopefully we do remember how the numbers are classified, right? This is just a bit of information. You can quickly screenshot if you'd like, but I'll be moving on to the following questions. Cool. Question 1, right? Let's determine the value of Q if A is equals to 2, B is equals to -1, and C is equals to -4. Let's leave our answer in the simplest route. For this question, what we'll be required to do is to simply substitute the values of A, B, and C into this equation right here, and then we'll solve for Q. Right, let's do that. We have, let me just write down this. Right, cool. We have Q is equals to the square root of B squared minus 4 AC. If we substitute the given values into this equation right here, we get a final answer of, let me just put that in my calculator real quick. We have B squared, which is -1 squared, minus 4 multiplied by 2 multiplied by -4. We then get a value of square root of 33, right? And now my question for you guys is, based off of the number system and how we classify numbers, what would you say this is? Would you say this is a natural number, whole number, integer, rational number, irrational? Can you just leave your answers in the chat for me? I think it's right. So the answer for that question was the square root of 33. How do we then define it? Pilani says it's a irrational number. Do we all agree with her? Okay, yes, that is correct. The square root of 33, give me a second, is indeed an irrational number. We know this because it cannot be written as a fraction, nor is it a whole number. So yeah, that is the correct answer, right? And now our next question is, between which two consecutive integers will Q lie? Bear in mind, Q is the square root of 33. If you write down the value of Q, we have Q is equals to root 33. If you punch that into a calculator, we get 5,744, and it just goes on and on and on. The question here is to determine which two integers Q lies between. The answer for this question will then be Q lies between 5 and 6. Right. Let's move on to the next question. I hope that I'm moving at an okay pace. Can I just get confirmation in the chat? Should I slow it down? Should I speed it up? All right. Oh, Tehofato is saying slow down. Slow down a little bit. Okay, cool. I will slow down a little bit. Do you need me to, if at any point you have questions, please drop them in the chat below, or rather unmute your mic if no one else is unmuted at the time. How does that sound? Okay, slow down. All right, I'm seeing messages to slow down. I will slow down and I'll just quickly go over what you've just covered thus far. Okay, cool. Let's go back to what we were working on. Fine. Like I mentioned before, we are covering the number system for this section in particular with the questions that we deal with. Under the number system, we have real and unreal numbers. Or another word for unreal numbers is an imaginary number. The type of numbers that are imaginary or unreal would be numbers that cannot exist. An example that I could give in this case would be if you divide a number by 0, we cannot compute that. That's why if we put that into a calculator, we get a math error. Sorry, could you please repeat that? Okay, I cannot share that. If you could please drop your question in the chat and I'll be sure to read it. Okay, cool. Let's go on. Like I mentioned with the number system, we have real numbers and imaginary numbers. Under real numbers, we have rational and irrational. Irrational numbers are numbers that cannot be written as a fraction. An example would be Q that we calculated in the question that we've just done. If we have Q is equals to the square root of 33, we cannot write this number here as a fraction. Therefore, it is an irrational number. Right. Under rational numbers, we have fractions and we have integers. For fractions, we have proper and improper fractions. And for integers, we have whole numbers. But I need you to bear in mind that recurring numbers can be written as fractions. Right? Cool. And under integers, we have negatives and whole numbers. Negative numbers would just be a -1, -2, -3, so on and so forth. And under whole numbers, we have numbers starting from 0 up until essentially infinity. So 0, 1, 2, 3, and goes on and on like that. Now under whole numbers, we just have 0 and natural numbers. Natural numbers exclude 0. Right. I hope everybody is good and sorted with that. Let's move on to the following question. Represent x is an element of -3 to 4 graphically. Right, let's do that quickly. For this question here, I need you guys to see that we have a square bracket over here and a round bracket over there. The square bracket means that is inclusive over there. Let me just write that down. Just give me a second. This means inclusive. That over there means exclusive. And now what this means for this question in particular is that x can be any number between -3 and 4, including 3, but excluding 4. What this means is that x can be -3, but it can't be 4. X can be 3,99999, but it can never be 4, as given by these brackets over here that note whether or not it's inclusive or exclusive. Cool. I'll just give you guys a few seconds to try represent this graphically, and I'll give you the answer and you can confirm whether or not you've gotten that correctly. Cool. I think 30 seconds should be fair. This is a fairly simple question if you know how to do it. In the meanwhile, let me check if there are any questions. Okay, let's see. Can you please show us how to write the whole sum out? May you please clarify what exactly you mean by writing out the whole sum and which sum you're referring to? See what Remofilo has to say. Referring from the last question, why do I get the square root of 31? Remofilo, you likely got the square root of 31 because you hadn't substituted in your values correctly. So if you can just confirm that your values are substituted incorrectly, then you'll be able to see how we get the square root of 33. Katlejo and Pinani are asking me to repeat. All right, let's see. Somebody else has gotten the square root of 31. Let's go back to the question and see exactly. Okay, cool. Hope you guys are following along. We're solving for Q in this case, and we've been given our values for A, B, and C. So let's just write it out. We have B is equals to -1 squared minus 4 multiplied by 2 multiplied by -4. If we simplify this, we have -1 squared is 1, right? These two negatives multiply by each other and create a positive. So we then get plus. If we multiply 4 by 2, we get 8 times 4. And if we simplify this further, we then get 1 plus 32, which then gives us the square root of 33. Right. I think the only issue that might have arisen, or the only issue that I could see possible, is that when you guys, or when some of you substituted in the -1 into this over here, b squared, you thought that it still remains negative. Whenever we have a negative multiplied by a negative, the answer is a positive. If we have a positive multiplied by a negative, our answer is negative. And a positive multiplied by a positive would be positive. I hope that clears up any questions that some of you had. Cool. Let's continue on and represent this over here. Cool. We were asked to represent x as an element of -3 to 4 graphically. In this case, we include -3 and exclude 4. Hello, sorry, do you have a question? Okay, I'll just continue on with my explanation. Right. Cool. So for this question over here, we asked to represent x as an element of -3 to 4 graphically. How we would do this is to draw a number line. So let's draw that out. We have a number line over here. On the left, we just add -3. On the right, we add 4. And now here's where you indicate inclusive and exclusive. Whenever you have the round bracket, which means exclusive, we put an open circle, an open dot. Okay? Whenever we have the square bracket, which means inclusive, we put a filled in dot over there. And the last step when it comes to answering this question is to just draw a line in between the dots. And this is how we would represent this graphically. I hope this explanation has been clear. Do I have any questions? Do you have any questions regarding this? Ngatek was asking, do we answer finally by writing a square root or round off to 2 decimal places? Ngateko, it depends on what the question paper states. In this case, we're just going to leave it as a square root. But sometimes you find that when reading the question or at the beginning of the question paper, it states round off all answers to 2 decimal places. In that case, you do that. Another example is if they tell you to leave it, I don't know, in simple form, or don't simplify further, something like that. But it really depends on what the question in the question paper states. Esther, you have a question. Do we write 0 between the 2 numbers? It's not required in this case, Esther. We just have to show or represent that we can represent what we were given graphically. I hope that clears any questions that you have. Cool. Are we all good and sorted on this? Do I have any further questions before I move on? Okay. If it wasn't specific on whether or not to round off, you can just leave it as the square root of 33. Kurula, I'm not sure which question you're referring to. Do you mind clarifying for me? And Dakaro was asking, should we write the numbers in the number line, including all numbers? Dakaro, it's not necessary. In the way that I've written it for the answer, the way that I've drawn it graphically, you don't have to add the numbers in between. Ramafule, I don't get how to represent X elements graphically. Okay, Kurula, I'll give a very quick explanation on how to do this, and hopefully it also answers Remofilu's question. Remofilo, you're saying you don't get how they represent X graphically. That is just what I've done over here. In order to represent this over here graphically, we have to draw a number line. And on that number line, we have to indicate which numbers are included and which numbers are excluded. Included means the square bracket. Excluded means the round bracket, like I have written and highlighted and shown over here. And the last step would be to draw a line connecting the two. Let me give a different example to make sure that we all are 100% on this. If we represent y as an element of, in this case, let's choose 2 till 6, right? What we would then do is to draw a line. You guys have to just use a ruler. We draw our line, horizontal line. We draw these vertical lines here showing 2 and 6. Note that the numbers have been put in ascending order from the smallest here, which is the 2, to the biggest, which is the 6. On top, we indicate whether or not the numbers are included or excluded. For our 2 over here, we would put a round or a hollow circle, the empty circle, because it is excluded, as noted by this over here. Okay. On the right here, on top of the 6, we put a filled in circle because it is included, as noted by this square bracket over here. And then the last step was to just draw a line in between this, right? I promise you guys, this is 3 marks in the exam. So please be sure, or please make sure that you understand and practice, or at least remember what I'm going to write here. Okay, cool. For our next question, right? For which values of x will this equation here be undefined? First of all, we need to know how exactly an expression or equation will be undefined. Something is only undefined if it is non-real. And in this case, because it is a fraction, it will be unreal if the denominator is equal to 0. I need you to remember that whenever we have any number, let's say we have any number divided by 0, this is undefined. Right. So in this case, sorry, I hope whoever has their mic on may please mute it unless they have a question to ask. Let's follow on. Let's continue on with this. So for this question, we need to find the values of x for which this expression over here is undefined. We know that expressions are undefined if the denominator, which is this part here on the bottom, you know, a fraction would be undefined, or any expression is undefined if the denominator is equal to 0. Cool. That's just information that we have to know. The next step would then be to solve for x, which would essentially be this right here. Let me just write this down. This will be undefined for all values of x where the denominator is equal to 0. Because whenever we have a number divided by 0, it's undefined. Cool. So our next step here is to solve for this over here. Right. I'm going to give you guys a few seconds to solve this. Should be a quick and straightforward calculation. And I will check in on the chat to see whether or not we're following along on how to do this. In the meanwhile, if you have any questions, please post them in the chat below. I hope everybody is okay with these questions. Let me just check the chat and make sure that you do indeed know how to solve this. Okay, cool. Manjantla says x is equals to -3. That is correct. That is the correct answer. Well done, Manjantla. Well done, Mashori. EC. Well done, Angela and Dakaro. And whoever else had x is equals to -3. That's very good. Retabile. The topic we did before this was just the number system, number line. That's it.
Okay, thank you.
All right. Okay, great. It seems as though everyone's on the same page. We do have x is equal to -3. That's very good. Well done, everyone. Let's continue on. I'd say the section we just covered was what I can call the easier part of paper 1. Let's move on to the more demanding or challenging things. Right, for your guys and my benefit, just for everyone's benefit, I have posted here the rules of exponents here. We are now going to work on exponents as our second section that we have to cover. Right. Please familiarize yourself with the... Yes, that is correct. For the previous question, we are moving on to exponents now. Cool. Please familiarize yourself with the laws of exponents, as we will be using these to be solving the questions to follow. Right, question 2. Question 2 asks us to simplify this expression. Right? I'm going to give you guys a minute or two to solve this, and I will then check in to see whether or not everybody knows how to work with the law of exponents. Right, we're working on question 2. We're trying to solve, or we're trying to simplify this expression over here. Hope everyone's doing well with this question.
Madam.
Hello, hello. Do you have a question? It doesn't seem like it.
Can you zoom in on question 2? Thank you.
You're welcome. Right. Let's see. Let's now simplify this expression and see whether or not we know or understand how to work with the law of exponents. We have 3 times 2 to the power of m minus 4 times 2 to the power of m minus 2 all over 2 to the power of m minus 2 to the power of m minus 1. Right. Let's simplify this. I'm going to start with the numerator, which is the expression on top of the fraction. We have 3 multiplied by 2 to the power of m minus 4 times 2 to the power of m times 2 to the power of -2. We have that all over 2 to the power of m minus 2 to the power of m times 2 to the power of negative 1, right? If we simplify further, we then have 3 times 2 to the power of m minus 4 times 1 over 2 squared. I need you guys to remember that whenever you have an expression with a negative exponent, it is a fraction. So I'll just give you an example of what I mean. If we have 3 to the power of negative 4, this is a fraction. It is 3 to the power of, or it's 1 over 3 to the power of 4. That's what I mean when I say that whenever you have an expression with a negative exponent, it's a fraction. Cool. Let's continue on with our expression, with our question. Fine. So that's the numerator. Let's move on to the denominator. You have 2 to the power of m minus 2 to the power of m times a half. If we simplify this further, we get 3 times 2 to the power of m minus 4 over 4, or rather, let me not jump steps to make sure that everybody understands. We have 3 times 2 to the power of m minus 4 times 1 over 4, because 2 squared is 4, and we have that multiplied by 2 to the power of m. We have this all over 2 to the power of m minus a half 2 to the power of m. Cool. If we simplify further, we get 3 times 2 to the power of m minus 4 divided by 4, 2 to the power of m, which is then all over 2. Hold on. Yeah, we have that all over half times 2 to the power of m. Some of you may be wondering how I went from this over here and got that. What I did was a half 2 to the power of m. I need you guys to remember that this expression in front is multiplied by 1. It's the same thing. 1 times 2 to the power of m is equal to 2 to the power of m, right? And because these over here are like terms, let me just change the color of this highlighter. These over here are like terms, right? We can then subtract these constants in front of the 2 to the power of m. And that's how we then end up with half times 2 to the power of m. Because in this case, it is this 1 minus a half. And we have all of that multiplied by 2 to the power of m. I hope we all understanding how I got that. Let me now move on to finishing this question over here. Right. If we simplify this further, we then have 3 times 2 to the power of m minus 1 times 2 to the power of m. And we have that all over 2 to the power of negative 1 times 2 to the power of m. Do you have a question? Okay, I'll just continue on with what I was doing. Fine. Let's continue simplifying this expression. If you simplify the numerator, we have 2 times 2 to the power of m divided by 2 to the power of negative 1 times 2 to the power of m, right? It's the same thing I explained previously, where because this over here and that are like terms, we can then subtract, or we can add or subtract the constants in front of this 2 to the power of m. Cool. And let's simplify this and get our final answer. We then end up with, and also need you guys to recognize that we also have like terms over here. We can cancel out this 2 to the power of m on the top and the 2 to the power of m on the bottom. So let's cancel that out. That leaves us with 2 over 2 to the power of negative 1, right? Now, what happens when we have a negative exponent in the denominator? What we then do is to move this to the top, right? And make the denominator positive. We would do that by multiplying the 2 on the top by 2 to the power 1. So this over here simplifies to 2 multiplied by 2 to the power of 1. And then we then get a final answer of 4. I'll explain one more time. In order to go from this over here to that over there, what we do is that we take this denominator over here, which has a negative exponent, and we multiply it by the numerator. And when we multiply by the numerator, this negative exponent becomes positive, and that's how we go from this over here and get that over there. Hope everybody's clear on that. If you have any questions, just post them in the chat. And if you don't, then we can continue on with what we were doing. Just gonna move all of this there. So we have space for the next question. If you have any questions, please post them in the chat and I'll read and try to reply to them quickly. Okay, Puseleto, that 4 is the final answer. That is correct. Mafula, I hope my explanation has showed you how exactly we get 4 as a final answer. How do you simplify 4 divide 4? Not too sure what you mean by that. Babalo, if you got 4 but you use a different method that checks out, that is still good. That's okay. Kahiso has a question. But sir, when you switch the denomination, I'm hoping you mean denominator, don't we divide and get 1? Kahiso, we don't divide and get 1. I hope that my recent explanation has just showed you how exactly we do that. Is everyone clear on this question? You can just put a Y for yes or N for no. Busisiwe, what exactly do you mean when you say you don't understand it? Could you clarify, please? As well as for those who say that they don't understand. Okay, it seems a few of you, it seems as though I've lost track of a few of you. Do you mind just quickly explaining at what point I've lost you so that I can quickly explain? And we can continue on with our session. Babazila is asking, I want to know how we moved from 4/4 to 1. We didn't move from 4/4 to 1. Oh, sorry. Let me see. Babazila, 4 divided by 4 is 1. I'm not actually even sure what exactly you mean by that question. Could you please explain further or word it in a different way? That guy was asking us to use another example. Okay, cool. We move on to the next question because the next question is still on exponents, or the law of exponents. The law of exponents is a section that quite a few students struggle with. So don't feel demotivated if you haven't gotten this one. Hopefully, as we continue on with our examples, it'll start clicking and making sense for you. Let's continue on. Right. We are now going to simplify this expression over here. I'll rewrite it in case you guys can't see properly. This is 4 to the power of x multiplied by 8 to the power of x plus 1. And we have that divided by 32 to the power of x plus 1. Cool. For this one, I'm just going to give you guys 2 minutes. I'm going to challenge you guys to do it in 2 minutes. And I'm hoping that you can draw on the law of exponents in order to answer this one and get a final answer. Hello, do you mind speaking closer to the mic, please? Okay, we might have to pick up the pace a bit because we are running a bit behind schedule. So I will go on and simplify this expression, and hopefully you guys have gotten the same answer. And for those who are still struggling, I'm hoping that this explanation that I do for this question and the one to follow will help you guys. Cool. Let's start here. How do we simplify this over here? Let's start by working with the numerator. In the numerator, we have 4 to the power of x multiplied by 8 to the power of x plus 1. Right. What we can do over here is to take everything down into its prime factors. And what I mean by that is to take our 4, we know that 4, right? 4 is equals to 2 to the power of 2. So we can just substitute this in its place. How we do that is by writing 2 to the power of 2, and we have that to the power of x, right? And now let's work with the 8. 8 is equals to 4 times 2, which is alternatively equal to 2 to the power of 3, because you know 4 is 2 squared. And then whenever we have exponents of the same base multiplied by each other, we add the exponents. That's how we get 2 to the power of 3. Excuse me. That's how we get 2 to the power of 3. Right. So we can substitute this 2 to the power of 3 in place of the 8. Let's do that. We have, instead of the 8, we are writing 2 to the power of 3, right? And we have this expression, 2 to the power of 3, and we have that raised to the power of x plus 1. We have this divided by 32 to the power of x plus 1. Now, let's put 32 in terms of its prime factors, right? What is 32? 32 is 16 times 2, which is 8 times 2 times 2, which is 2 to the power of 3, times 2, which is 2 to the power of 5. Remember that whenever we have exponents of the same base multiplied by each other, we just add the exponents. That's how we have 2 to the power of 5 as 32. Hope everyone's on the same page. Let's go on and substitute this 2 to the power of 5 in place of the 32. Let's do that. We then have 2 to the power of 5 as the denominator, raised to the power of x plus 1. The next step here is to call on this rule right here, the power of a power rule. I cannot stress this enough. It is very, very, very important that you guys remember the law of exponents. I find that the students who struggle with exponents, the section, are the ones that haven't memorized the law of exponents. So please take a screenshot here if it helps you or if it would help you. Otherwise, you can just do a simple Google search and find the law of exponents written out for you. Right. Let's go on to simplifying this question. Cool. Like I said, we're using the power of a power rule for this one. This then means we have, for this, if you're working with this one over here, we take 2 to the power of 2 multiplied by x. So it's going to be 2 to the power of 2x. Let's write that out. We have 2 to the power of 2x, and we have that multiplied by, and it's the same thing here. We have this 3, and we multiply this 3 into this expression over here. How we do that is just have 3 times this, whatever's inside the brackets. And as you know, we just distribute this 3 in, meaning that we end up with 3x plus 3. Well, let's write that out.
So how did you get up with 2 to the power of x? Isn't it supposed to be 2 to the power of 2x?
Yes, it is. Thank you very much for correcting me. Yeah. Now, let's deal with the denominator. Like I explained, with the numerator where we have 2 to the power of 3 to the power of x plus 1. In this case, our 5 is distributed into the x plus 1. We then end up with 2 to the power of 5x plus 5. Right. We're trying to simplify this as much as possible. How we do that is to, let's just write down this expression in a different way. Let's separate our exponents in this case. Let's write down 2 to the power of 2x multiplied by 2 to the power of 3x multiplied by 2 to the power of 3. You have this all over 2 to the power.
Sir,
Yeah.
it's supposed to be 2 to the power of 5x plus 1.
For which one?
Or 2 to the power of x times 2 to the power of 3 plus 1.
Right.
No, you made a mistake.
For which one?
For the denominator, sir, he said 5 times. It's right, so it's 5.
No, they are confused, sir.
It's supposed to be 1.
It's
No,
5
it's
because
not
No, it's
supposed.
3 because it's multiplied.
Wait,
Okay,
so I
for the
have a
denominator.
question.
Okay.
My question is, right, you see you said 2 to the exponent of 2x multiplied by 2 to the exponent of 3x.
Mm-hmm.
Then you said multiplied by 2 to the exponent of 3. Where do we get the 2 from? I understand the exponent of 3, but where do
Yeah.
we get the 2 from?
Are you referring to the numerator?
Yes.
Okay. We'll have to go back to this over here. Sorry, can we just have one at a time? I'm trying to explain here. Can whoever's talking please mute their mic? Cool. Let me also
Can we please continue?
Right.
Okay,
Okay, I'll just continue on. So your question was asking why we have 2 to the power of 2x over here. Is that right?
Yes. Yes.
Okay, cool. It's because of this over here. We have 2 to the power of, because remember we have the 4. 4 is 2 to the power of 2. So we then get this, right? Because we know it's 4 to the power of x. In place of the 4, we just substituted in 2 to the power of 2. And we have that raised to the power of x. Are you following along?
Yes.
Right. The next step is to multiply the exponents together because it is one exponent raised to the power of another. Does this make sense?
Yes.
Right. If we multiply these two together, we then get 2 to the power of 2 times x, which is the same as 2 to the power of 2x. Does that make sense?
Yes.
Yes,
All
sir.
right. Have I answered your question?
Wait, pardon? Okay, I'm still a bit confused. I'm
When
so
it comes
sorry.
to, it's all right.
You see, your final answer, like the
Mm.
final part, where it says, times 2 to the exponent of 3.
Yes.
Yes, that's the only part that conflicts. Wait, let me just
That
quickly
shall
see.
remove.
Yes,
Okay.
that confuses.
Right. I went from 2 to the power of 3x plus 3, right? And I went to 2 to the power of 3x times 2 to the power of 3, right?
Mm-hmm.
Like I said, whenever we have two exponents of the same base, in this case, our base is 2, right? When we have two
Yes.
exponents of the same base multiplied by each other, what do? We add the exponent. So we're adding this 3x with the 3, and that's how we end up with that. And it also works in reverse. We can take this over here and break it down into 2 to the power of 3x multiplied by 2 to the power of 3. Does that explain everything?
Yes, thank you.
You're welcome. Like I said, I think the only reason why you guys are stumbling is because you're not really familiar with the law of exponents. Are you following? In this case, the reason why I was able to split up the 2 to the power of, the reason why I was able to split this up into that was because I used the multiplication rule over here. Are you following?
Yes, sir.
Yeah. So please make sure you guys familiarize yourself with the law or the laws of exponents. Right, let me continue on and finish this off. We're not done simplifying this. Cool. Here's the next part. Whenever you have of the same base divided by each other, we subtract them. This is the division rule as outlined over here. Since these over here have the same, excuse me, let me go back. Yeah, since these over here have the same base, which is A, right? Whenever we divide them, because it's A to the power of X divided by A to the power of Y, that's how we end up with A to the power of X minus Y. This is just the law of exponent that we have to learn and memorize. And that's what we will use for this question over here. Cool. Now, let's just simplify this first, right? In the numerator, what we can do is to take this over here and add it with that. It is the same base. We can add them together because they're both multiplied by x's. These are like terms. So let's simplify. We have 2 to the power of 2x plus 3x multiplied by 2 to the power of 3, right? If you guys know of a way to solve this without using my method or using a different method, so long as you arrive at the final answer and it's correct, then everything is good. Cool. Let me simplify this. We then end up with 2 to the power of 5x multiplied by 2 to the power of 3. You have that divided by 2 to the power of 5x times 2 to the power of 5. Let's eliminate our like terms in both the numerator and the denominator, which is the 2 to the power of 5x. That then leaves us with 2 to the power of 3 over 2 to the power of 5, right? And because of the rule that I just outlined to you, whereby if you have two exponents of the same base divided by each other, we subtract the exponents. We then end up with 2 to the power of 3 minus 5, which will then be 2 to the power of negative 2, which is 1 over 2 squared, which is then 1 over 4. This was a bit of a tricky question. And so if you were able to solve it on your own and get the correct answer, then well done. I'm just going to check the chat now to see if we're all on the same page. Somebody's requested access to meeting settings. I'm just going to deny that. Cool. Let me check the chat now. No one sounds like got 1 over 4. Well done. Let's see. Are there any questions? Sino Tando also got the answer right. Well done. Well done to everybody who got the answer correct. Are we all on the same page when it comes to what you've just covered? Pilani, if you got it right but use a different method, that's still great. When it comes to mathematics, as long as you're applying the correct rules and you reach the final destination, which is the correct answer, then your teachers will be happy. You still get all the allocated marks. In this case, because this is a session in which I am trying to fill in the gaps that some people may have in their knowledge, I am taking extra steps in solving. So if you're able to do it in fewer steps and it makes sense and you get the final answer, then that's correct. Mamelo, we are currently doing exponents. Sienna got the same answer. Well done. All right. Tokozile, well done as well. Cool. Are we all ready to move on? Let me just get a quick Y or N. Y for yes, N for no. How many marks would a question like this typically count? Well, it depends on how complex it is to begin with, right? I can quickly check for you here to see what the mark allocation for this would be. Just give me a few seconds. A question like this would typically be maybe between 3 and 4 marks. Yeah. Lucia is asking. Okay, another question. Mamelo, Euclidean Geometry is going to be in tomorrow's session. That's when we'll be doing paper 2 content. So please check back in tomorrow. And yeah, or if you really need help today, then you are more than welcome to check out our social media pages. We are on YouTube. We do cover grade 10 Euclidean Geometry. We do have TikTok videos. You just have to search for them. But otherwise, our YouTube channel is there. Please be sure to subscribe and follow all our social media pages. It's to your benefit, guys. Trust me. Oh, thank you. Orinele Karabo, thank you very much. I really appreciate it. Lebo is asking for another example. We'll do another example. Functions are going to be at the end, which is why I do want to progress and quickly finish with exponents, but it seems as though people are struggling. Our social media channels are just the learning space. Just search up the learning space on YouTube, on TikTok, on Instagram, and you'll find us. Hold on, I'm sending to everybody else. The learning space. Just search us up and you will find past papers and so much information that will help you guys excel. Let me see if I can admit more people to the chat. There's nobody waiting in the lobby, so I think they've opened to now. I'm going to do one more example, but I do have to move on to the next section, which is number patterns. This example is a fairly easy one. We did start off with the hard ones. But yeah, for this example, let's just solve for x. Actually, it might be tricky, but let's just continue. We are solving for x. I'm going to give you guys a minute or two to solve for x. And after, walk through the question and see if everybody's on the same page. My tip for this one is to put all the numbers in the same base. The base is 3, so try put 36 as an exponent. Or try put 36 into an exponent, having the base as 3. Yeah. Okay. I hope you guys have gotten an answer for this one. I hope you can actually see it. The question is 3 to the power of x plus 3 to the power of x minus 1 equal to 36. Have you guys gotten the answer? Let me see in the chat quickly. Relebohile, you have x is equal to 2. Ramafilo, you have x is equals to 3. Let me solve for this and I'll be able to tell whether or not you guys are correct or on the same page. Let me go back here. Cool. Let's solve for this, right? We have on the left-hand side, everything is in the same base essentially, right? Which is 3. On the right-hand side, we have 36. We know 36, or we don't know. If you put 36 as a prime factor, right? If you use that whole prime factor method, we then have 36 is equals to 3 to the power of, is 3 to the power? Okay,
12.
hold on.
3 to the power of 12.
It wouldn't be 3 to the power of 12. It's 36 is equals to 3 times 12. Are you following? 3 to the power of 12 is one incredibly big number. Right. So let's just try put 36 into its prime factors. We have 3 multiplied by 12, which is 3 times 4, which is 3 squared times 2 squared. 4 is 2 to the power of 2, right?
So
Yeah.
So, excuse me, so let me.
Sorry, your sound is a bit muddied up. Could you please repeat that for me, please?
No, continue. So, yeah.
You what?
So-
You can, yeah.
so
Yes.
it's 6 to the power of 2.
6 to the power of 2. Yes, it is 6 to the power of 2. But we
Yeah.
can simplify 36 is equals to 6 to the power of 2. That is correct. But we can also put 6 as that prime factor exponent thing, whereby we have 3 times 2. Because we can substitute that into the place of 6. Are you following along? And then because we have these numbers, the product of two numbers, 3 times 2, and we raise that to the power of 2, what we then do is distribute this 2 inwards into the exponent. So we then have 3 to the power of 2 times 2 to the power of 2. Could you please repeat that? I didn't hear you.
I'm so lost, sir. Because how did you get to 36 is equals to 3 times 2, 3 times 12?
36 is equals to 3 times 12. Remember,
Okay.
I think it was in primary. I'm not sure, guys. But I think there was a point in which you were required to learn your times tables up until 12.
Yes, sir.
Yeah. So
Okay,
36,
so we find the multiples of 36, like the factors.
yeah, you have to put 36 in its prime factors. You can do that what's that method? The ladder method, where you divide by 3 over here on the right, you then end up with 12. You divide 12 by, say, choose 2, you end up with 6. Divide 6 by 2, you end up with 3. Divide 3 by 3, you end up with 1. And then you multiply all these together, you get 3 squared times 2 squared. Does this ring a bell?
Oh, okay, yes, now I understand.
Okay, great, perfect. Let me just erase all of this here. Right. So when we put 36 as a product of its prime factors, we end up with 3 squared times 2 squared, right? And here on this side, if we now separate this over here, if you separate this over here, we can then turn that into 3 to the power of x times 3 to the power of minus 1. Right? Cool. I'm hoping you guys see that there is a like term present. Maybe
Yes.
better for you.
Sir,
Yeah.
why are we multiplying 3x by 3 to the power negative 1?
Because you've just broken this down.
Okay, no more.
Oh, okay.
Yeah. Yeah, we've just broken this down, and this is the multiplication of a power rule or multiplication rule over there. Are you seeing it?
Yes, sir.
All right.
Okay, sir.
Cool. I'm going to continue on.
Oh, okay.
Yeah. Like I said, guys, it's very important that you memorize the laws of exponents. It will come back. It will always come back to bite you in grade 11 and in grade 12 if you don't make sure that you know them, all of them, off by heart now. Exponents is a big stumbling point in grade 10. So you can, or if you're not comfortable with this topic, then you will lose a lot of marks. But I have to pick up the pace so that we can actually cover all that I've set out for us to do. Cool. Like I said, there is a like term over here. that we can take out, right? We then get 3 to the power of x multiplied by 1 plus, in this case, we have 1 over 3. We have that is equal to 3 to the power of 2 times 3 to the power of 2. If we simplify the left-hand side, we end up with 3 to the power of x multiplied by 4 over 3. And that, you okay?
Excuse
Hello?
me, sir.
Mm-hmm.
So, like, why do we have one? Like, where does the one come from?
Which one are you talking about?
From
This one
3
over
to
here.
the power of x, open bracket, 1 plus 1 over 3. The first
Oh,
one, yes, that one.
Okay. It's because 3 to the power of x is the same as 1 times 3 to the power of x, my understanding. It's the same
Yes,
thing.
sir.
So we just removed our common term, which is 3 to the power of x.
No. Please re-explain again.
Sorry?
Please explain again.
So, sir, can you please explain it again?
Okay.
Can I kindly ask?
What's your question? Ask, and then I'll answer both of them, because I do want to make sure I cover functions, because it is important for you guys' exams. What is your second question before I answer that first one?
So on that one, say, are we supposed to like factorize the 3x plus 3x, which is the common factor is 3x, and you're remaining with 1 plus, I don't know how you got that one. Oh, yeah, I see how you got it.
Okay, cool.
So can I ask?
Okay, hold on. I need to answer those two guys' questions first, because they didn't ask it
Yes.
first. Okay, right.
Okay. So,
Like I
let's
explained.
see.
Hold on.
Yes.
Like I explained, 3 to the power of x, this is the same as that, right? So for this over here, what I did was, because it's 1 multiplied by 3 to the power of x plus 3 to the power of x multiplied by 3 to the power of -1, I removed this common term, right? I took it out of the bracket, meaning we then get 3 to the power of x multiplied by, in brackets, 1 plus 1 over 3. 1 over 3 is the same as this, 3 to the power of -1. Is it clear now?
Okay, sir. It's clear, sir.
Okay, cool. I need to rush through these questions, unfortunately, guys. But, right. So let's simplify the left-hand side. We have 3 to the power of x, right? Multiplied by 4, which is 2 to the power of 2, right? 2 to the power of 2. And then, because it's divided by 3, we can still write it as 3 to the power of -1, right? Cool. The next step is, because we're trying to solve for x, right? We need to have the left-hand side and the right-hand side have the same bases, right? We need them both to have base 3, a base which is 3, and a base which is 2. So on the left-hand side, we have to simplify it or put it in that manner. We then get 3 to the power of x minus 1, and you multiply it by 2 to the power of 2, right? The reason I could do that is because this is multiplied by that, right? And then I just added the exponents together because we are multiplying exponents of the same base. And that's how I get this over here. Fine. Now we can solve for x, because if we divide both sides by 2 squared, hold on, we then end up with 3 to the power of x minus 1 is equals to 3 squared, right?
Can I ask something?
Yes. Yes, you can ask your question.
So can you please continue?
Okay. Right.
So,
We're solving for x, right? Now we have the same basis. And because we have the same basis, we can equate the exponents. Now we have x minus 1. Therefore, x minus 1 is equals to 2. And if we solve for x, we have x is equals to 3. Right. And that is it for exponents. For this question in particular, where you had to solve for x, you had to get the same basis or the same base on the left and the right-hand side. And only then could you equate the exponents.
Can I ask?
Yeah.
So do you always have to follow these steps?
You don't always have to follow these steps as I've laid them out, but if you're able to understand how to apply the law of exponents and reach the same answer, then everything's good.
Okay.
Okay, do you have any more questions, guys?
Yes.
Yes,
Okay.
sir.
yes,
Yeah.
sir.
So on top there where we had like terms 3x and 3x. Why didn't you add the 3x plus 3x? Why did you just leave it as 3x?
You can't. Which one are you referring to? Which?
So on top we had like terms 3x
Over
plus
here.
3x and
Over here.
yes, sir. There.
We can't add these two together because of this
No, sir,
over there.
underneath.
Over there.
Yes, sir.
You can do it and you'd likely still end up with the same answer. That's the thing with math, guys. If you apply the correct methods, you can still reach the correct answer.
So we're still going to write if it was 6x times 3 to the power of negative 1.
No. You wouldn't get 6x.
By adding 3x and 3x.
These are like terms, right? And because they're like
Yeah.
terms, you add the constants together. Are you following?
Yes, sir.
Yeah, so in that case, you wouldn't end up with 6.
Okay, thank you.
Yeah. Like I
So-
said, guys, please familiarize yourself with the law of exponents, and yeah, it'll just make life so much easier. Yes, please ask your question.
Is other method to do
So,
this?
so by x equals -1, we carry over the -1 and then say 2 plus 1, right?
Yes.
Okay, thank you.
No, say quick question. So like now, where does the 2 to the power of 2 come from? On your left hand side, to the 3
It came
to
from
the
the 4. It came from the 4. 4 is the same as 2 to the power of 2. And that's how I got that over there.
Oh, okay, thanks. Continue. Thanks, sir.
So there is a need to follow this method.
Sorry, please ask your question. Hello?
So we
Can
say,
you please
can you
repeat for me?
continue?
Okay, I'm just going to continue on, guys. Sorry. Let's move on to number patterns. I just want to check what other sections we have to cover. Yeah, guys, we still have a lot, eh? We did take time, so I might have to run through all the stuff here. Cool. Right. Number patterns, right? Over here, we have an example in which we are working out the general term for a linear or arithmetic number pattern. Are you following? Right
Yes,
there.
sir.
Cool. In question 3, that's when we start using it. So let's get to solving question 3. We have the pattern 1, pattern 2, pattern 3. The patterns are the first 3 terms of a sequence for which the value of the term is given by the number of sticks in the pattern. We have to write down the number of sticks in each of the first 5 patterns of the sequence. That's number 1. And then number 2 is asking us to write down the general term, Tn. And then number 3 is solving for T131. Cool. Let's just write down the patterns over here, pattern 1, pattern 2, and pattern 3. In pattern 1, we have 3 sticks. In pattern 2, we have 1, 2, 3, 4. We have 5 sticks. And in pattern 3, we have 1, 2, 3, 4, 5, 6, 7 sticks, right? We have a common difference of 2. And our first term, which is A, is 3. So we can get the general term, right? Our general term in this case would be En is equals to A, which is 3, plus our common difference, which is 2, multiplied by N minus 1. Cool. It's asking us to write down the number of sticks in each of the first 5 terms of the sequence. All we have to do is substitute 4 and 5 in, and then we get all of the first 5 terms of the sequence. It starts off as 3, goes to 5, goes to 7. The next one would be 9. You can substitute 4 into here and it'll work out. And then the one after that would be 11. Yes.
Sir, I'm sorry, but what if you wrote 2n plus 1? It's still okay.
If you wrote
2n plus 1 as your rule for tn.
well that wouldn't as your general term. If it works out,
Yes.
3 plus 2n minus 2, it's the same thing. It works out to be 2n plus 1. Right. This is just different ways of writing out the same general term. Cool.
Sir,
Yes.
I'm so sorry for interrupting.
Right.
Can I ask, is this pure maths? The number pattern, is it pure maths or maths lit?
This is pure maths. Do you guys not cover number patterns in pure maths?
No, we didn't.
No, sir, we haven't.
Yes, so we haven't covered number
The
patterns.
patterns, yes.
Yeah.
Okay, some of you have covered it. It seems as though some of you haven't. So it could be a difference in maybe schools. Some schools have such.
Sorry, sir.
Yes.
Sir. Sir, isn't the formula like 2n plus c?
It is, but it's what would C be? You'd have to solve for C, don't you?
Like
And if you solve
the constant term. Oh, actually.
Works out and gives you the correct general term, then it's all right, guys. Guys, we are running a bit behind schedule, so I'm gonna just quickly do this. Number patterns are an easy section, so I'll just do this one example, and then we can move on to equations and inequalities, and then go for functions and graphs. Right, so the general term, we did work it out at the top. You can write this over there, or you can write this. It's the same thing, guys. If you're solving for t over the term at 131, all you have to do is substitute 131 in place of n. You then end up with, let's just do t131 is equals to 2 times 131 plus 1. And that gives us 262 plus 1, which is 263. Simple and straightforward at this point. That's just an arithmetic number pattern, right? I'm going to skip this question so that we can go on to equations and inequalities, right? Right, so question 4, equations and inequalities. I'm going to give you guys 2 minutes to solve this one. And when you're done, I will do the answer and you guys can check and compare. All right, your time starts now.
Can I ask a question?
Yeah, you can ask a question. What's your question? Okay, guys, I hope we have solved this. I will get started on the answer. I'm just going to check the chat to see what you guys have thus far. Mohau, there is going to be a session tomorrow. Tomorrow's one is on paper 2. Let's see what else, if there are any other questions. I'm not sure which question, because I'm not sure what you're referring to. But yeah. Okay, cool. Just going to continue on. Let's solve for x in this inequality. We're presented with fractions. So the first light bulb in your brain should be to multiply everything by the lowest common denominator. In this case, our lowest common denominator, our LCD, is equals to 3 times 2, which is 6. So we have to multiply both sides of the inequality by 6. So let's do that. We have x over 3 multiplied by 6. And then that's on the left-hand side. On the right-hand side of the inequality, we have x over 2 plus 1, and all of that is multiplied by 6. Now let's distribute this in. We have 6x over 3 on the left side of the inequality. On the right side of the inequality, we have 6x over 2 plus 6. Let's simplify. On the left-hand side, 6 divided by 3 is 2, so we have 2x. On the right-hand side, we have 6 divided by 2, which is 3, so we have 3x plus 3. I'm just going to continue on that side. The next step is to get all our x's on one side. In this case, I'm choosing to bring all my x's to the right-hand side, right? Let's do that. So we have 2x minus 2x on the left. On the right, we'll have 3x.
Sorry, sir.
Yes.
Why did you divide 6?
Where?
Oh, sorry. You didn't. So I was confused. The third method.
No, it's all right.
So can I please ask a question? There where you said 6x is over 3 is greater than 6x over 2. I want to know, why did you multiply the 6 into the x but not into 2? Because I can see for 1 it became a 6, but for 2 it stayed the same.
It stays the same because it's the denominator. When distributing in this case, our 6, we multiply the numerator. The denominator stays the same.
Sir.
Thank you, sir.
Yes.
Sir.
Yes, you can ask a question. Yes.
So, in order for people not to be confused, you have to divide your 6 by 1.
What do you mean?
I mean, by where you say 6 divided by 1, because 1 multiplied by 2, it will exactly give us 1, because most of the people are confused. Why don't you multiply 6 into 3?
I'm not following what you mean. I'm sorry, I'm not following what you mean.
So making everything a fraction, which means 6 will also be a fraction. Like it will be 6 over 1.
6 over 1 is the same as 6. So that's just something that you guys have to know or understand.
Can you please explain
Yeah,
what you
that's
just
what I
told
mean.
right now?
May I please explain what?
What you just told right now, the 2x minus 2x.
Right, I'd like to do that, but I keep on getting questions. So please wait for me to finish the sum, and then we can start with the questions. All right? Cool. So from this over here, I go over there to simplify, right? When trying to solve for x, we have to get all our x's to the one side. In this case, I'm taking my x's to the right-hand side. How do I do that? I subtract minus 2x on both sides, so that on the left side, it then becomes 0, and on the right side, it becomes x plus 6. Okay? Now we want to isolate our x, so we take the 6 to the left side. And how do you do that? We subtract 6 on both sides. And that's how we end up with x is less than negative 6. That's our answer. Okay, cool. That was, I think, straightforward. Any questions on that? Let me check in the chat. Six is negative x. Yeah, okay, cool. Great. Let's continue on. Remember, guys, we do have one other section after this. Let me check. We are currently doing equations and inequalities, and I'd like us to do functions and graphs and make sure we have enough time to cover that. Okay. Cool. Let's move on to this next question. When some of you guys see this, you may start getting all anxious because we have this type of inequality over here, right? You don't have to overcomplicate it. You can solve it as a regular inequality, but just bear in mind, whatever you do to the one side, you do to the other. That's for a two-sided inequality. For this, that I will maybe call a three-sided inequality for the sake of explanation, you have to apply everything to each and every side of the inequality. When it's asking us to solve for x, we have to isolate the x. That is the goal, right? So let me write this down over here. We have negative 2 is less than x over 3 minus 1, which is less than or equal to 1. We want to isolate our x, so we have to do whatever necessary to this center over there. And whatever we do to the center over here, we have to do on the left, on the right, and the left-hand side. Okay? Let's do so. What's going to be the easiest thing to do first? We can remove this negative 1. How? We just add a 1 to the center. We add a 1 over here to the center. And if we do it over here, that means you have to add a 1 over there to the right side and the left side. We just add 1 everywhere such that we only have this in the center left. So let's do that. We then end up with minus 2 plus 1, which is less than x over 3 minus 1 plus 1, which is less than or equal to 1 plus 1. Let's simplify it. We have negative 1 is less than x over 3, which is less than or equal to 2. And now, what do you think the next step is? Is to multiply everything by the lowest common denominator. In this case, our lowest common denominator is 3. So let's multiply each and everything by 3. So we're going to multiply the center, the right, and the left by 3. So let's do that. We then end up with negative 1, oh, hold on. We get negative 1 times 3 is less than x over 3 times 3, which is less than or equal to 2 times 3, right? Let's simplify it. On the left, we have negative 3 is less than x. These cancel out over here. And then we have that less than or equals to 6. And just like that, we have solved this inequality. How did we do? Did we understand? Yes, no? Please just drop a Y or N in the chat. Yes, yes, yes. Okay, this is quite good. Some of you guys are saying no. Could you please send a message in chat to say exactly what you don't understand? Abazil is asking to see the question again. Go back. Okay, cool. Here is the question. We have to solve for x. Right, so what we did is when solving for x, we have to isolate it. And in isolating it, we apply any and all math transformations or however else you like to call it in order to get our x by itself. In this case, we started by adding 1 to each and every side of the inequality to end up with this over here. Okay. After we got that, we multiplied everything by our LCD, which is 3, and that's how we ended up with that there. After doing that, we just simplified it and ended up with -3 is less than x, which is less than or equals to 6. I hope that explanation clarified it for everybody. Why don't we multiply the LCD on the line? I'm not too sure what you mean by that. So can you make us do another one and ask questions like, where do we struggle the most? Pamela, sure, I can do another one for you. It is clarified to me, Telhafato. I'm actually quite glad. I'll explain using a different example, guys. Let's do this. -1 is less than -2x plus 3, which is less than or equal to 5, right? I'm going to give you guys 2 minutes. Well, let me make it 1 minute. I'm going to give you guys 1 minute to solve this inequality. And then I will check to see whether or not you guys are understanding how exactly this is done. If ever you're confused, you can just look at this one that I've done over here in case you need any clarification or just to see what steps I've made. Hope everyone is good and understands how to do it. We're trying to solve this over here. Okay, our minute is up. Hopefully we have gotten the answer. I will just start on showing you guys how to solve this inequality. Right, so we are solving for x in this one over here. How do you do that? You isolate it. So let's do that. Our first step over here is to subtract 3 on each and every side. Right, so we'll have -1, -3 over here on the left side. In the center, we'll have -2x plus 3 minus 3. And on the right, we have 5 minus 3. Let's simplify this. We then get minus 4 is less than minus 2x, which is less than or equals to 2, right? And now, after this, we have to get x on its own. So we divide everything by negative 2. So let's do that. Divide this by negative 2, divide that by negative 2, and we divide this by negative 2. If you simplify this, we then end up with positive 2, because whenever we divide a negative by a negative, we get a positive. We have that is less than x in the center, negative 2, and negative 2 cancel out. And we have that is less than or equals to negative 1. Whenever you have a positive divided by a negative, we get a negative. And this is our answer to this inequality. Are we all clear on that? Literally, physics is going to be next week. So please check our social media pages because we do publish our schedules there. All right, Pamela got it right. Babazile got it right. Sienna got it right. Great, perfect. Okay, you understand now? Quite glad. Let's move on. We have just a few minutes left, right? And these questions over here are asking us to factorize. I'm just going to run through factorization to make sure that we're all clear on it. So yeah, we want to factorize x squared minus x minus 20, right? Let's do so. We have our two brackets set up over here, right? And since we have a negative and negative, what we then do is have put an x over there and an x over there, right? And then right here, we'll have a negative and a positive. Right. Let's find out what our factors of 20 are. We know 20 is equals to 2 times 10 or 4 times 5. Right? And 20 is also equals to 20 times 1. Cool. And now, based off these three, the only one that we can use that'll end up with us having a negative 1x over here would be the 4 and 5, right? So we put our 5 over here and our 4 over there, and that's essentially how we factorize. We know the 5 is going to get the negative because this over here is a negative 1x. And if we distribute this in, we will still end up with the same expression. If we multiply that in, we end up with x squared plus 4x minus 5x minus 20. If we simplify this here, we end up with x squared minus x minus 20. Cool. In this one over here, which is 2a squared a minus b plus 8b squared b minus a, we would still have to factorize, or at least try to simplify the expression as far as possible. How do we do that? We can see that this over here is the same as that, except that this is multiplied by minus 1. That's why it's swapped around. And you'll see what exactly I mean by that. If we get b minus a, and you distribute negative 1 in, we end up with minus b plus a, which is same as a minus b. That is the same as this. Now let's continue on. Let's try simplify it. Excuse me. Try simplified, we end up with 2a squared, a minus b, plus 8b squared. We have now taken out or multiplied in a negative one, right? And then we can end up doing this. A minus b in the brackets over there. If we simplify this, we end up with 2a squared, a minus b, minus 8b squared, multiplied by a minus b. Since this and that are a like term, we can factorize it and have this as our final answer. We have 2a squared minus 8b squared, right? Because they're all multiplied by this over here, right? And we have that multiplied by a minus b. Cool. With this one, it's just a matter of being able to recognize that this and that are essentially made into a like term because they are both multiplied by this over here. Right. Let's move on. We do have to start with functions and graphs. Right. Over here, we presented with this function. F of x is equals to 2 to the power of x minus 1. Again, I apologize. We are running a bit over time. We did spend a bit too much time on the exponents. So I'll just try fit in as much information as possible into functions and graphs while ensuring that you guys do understand it. Cool. This function that we've been given over here is this over here. And I'm hoping you guys can remember the name. We've been given a parabola. We note that it's a parabola because there is a variable x in the denominator. Cool. Now it's asking us to find the equations of the asymptotes. It's asking us to find all values for which the function does not exist. In this case, it would be x is equals to 0 because if we substitute a 0 in, it'll be undefined. 2 over 0 is undefined. So that is one of the asymptotes. The second asymptote we'd have to figure out. You guys have to remember that hyperbolas have two asymptotes. They have a vertical one and a horizontal one. Let me just draw it out over there. If we have a function given us that, there's an asymptote there and an asymptote over there. Now it's time for us to solve for our second asymptote. How do you guys think we do that? Our second one, in this case, would be y is equals to -1. So let me write down the first one. So asymptote, remember an asymptote is just a line or value at which the function cannot exist. We know that x is equals to 0 because if we substitute an x into here, we get an undefined. And the second one is that y is equals to -1, right? Which should be the vertical. Cool. And now, how would we know that? It's because over here, right, you have to understand how exactly hyperbolic functions work, right? This value, this -1, tells us how many values it's shifted in the y direction, right? In this case, it's a -1 because it has shifted 1 down, right? And now, because it has shifted 1 down, we know that there's an asymptote at y is equals to -1. A regular hyperbolic function is like this over here, whereby there's an asymptote at x is equals to 0 and an asymptote at y is equals to 0. But because we've applied this transformation, the -1, we've moved it 1 downwards. It'll then end up looking like this over here, where we have an asymptote at -1 and at y is equals to -1. This is the y, that's the x. And an asymptote at x is equals to 0. In this case, we just have to understand how exactly a hyperbolic function looks and what the different values mean. Cool. Is everybody good and sorted with that? Let me just check the chat. Yeah, it is a hyperbola. At x is equals to 0 and at y is equals to -1. Yeah. Pilani, something we are still learning. Yay. Pilani, I'm hoping that this explanation has cleared up a bit, right? Nonchalant, I am seeing that you did get the previous question correct. Well done on that. Cool. Hyperbola. Right. Seems as though you guys are up to speed. Now, the next thing that it's asking us to do is to determine the y-intercept of f. F is our function as outlined over here. How do we find the y-intercept? How do you guys think we find the y-intercept? Let's see in the chat. Tabila, we do substitute. See that the y-intercept is also undefined since if x is equal to 0, it's asymptote. Yeah, but we can't let x is equal to 0 in this case, right? So we can't get the y-intercept of f. Just give me a second. Yeah. So there is no y-intercept of f. There is an x-intercept, right? And this is how you guys have to remember. In order to find the y-intercept, you equate x is equal to 0. But because we have an asymptote at x is equal to 0, there's no value there, right? Cool. Now, in order for us to find the x-intercept which exists, which will be this over here, what we do? We make y 0, right? So let's do that. So we make f at x, which is the same as y, is equals to 2 over x minus 1. We equate the left-hand side to 0, right? This is in order for us to find the x-intercept. In order to find the x-intercept, you make y 0. In order to find the y-intercept, you make x 0. Cool. Let's continue on. So for the x-intercept, let me change this to x. Cool. For the x-intercept, we equate y to 0. And now all you have to do is solve for x. You take this to the left side. We end up with 1 is equals to 2 over x. We multiply both sides by x so that we can take x out of the denominator. This and this cancel out. And we then end up with x is equals to 2. Cool. Now it's asking us to sketch f on a Cartesian plane. Show all intercepts with the x-axis and the asymptotes. This is straightforward if you know what a hyperbola looks like and how transforms are applied. Let me just show you one thing. If we have, for example, say we have g of x is equals to a over x minus p plus c, right? This over here tells us the amount of units it shifts in the x, in the y direction, on the y-axis. So it tells us if it's shifting up or down. This over here tells us if it's shifting left or right. Cool. If c is positive, it's shifting up. If C is negative, it's shifting down. When we come to this over here, if the P is negative, it's shifting right. That's the king, that's the catch. If P is negative, it shifts right. Whereas if P is positive, it shifts left. This is just the equation for, this is just the general equation of a hyperbola. If we had to sketch this out with the information that we now know, it would then end up looking like this. I'll just draw our axis over here. We have the x and the y. We know that there's an intercept at x is equals to 2. Let's write 2 over there. There is an asymptote at x is equals to 0. I'm just going to write that down, note it with a dotted line. And another asymptote at y is equals to -1. Cool. Let's sketch it out. It's going to be like that over there. Obviously, you guys can draw it neater if you have your rulers with you, but this is just how the function would look. In this case, it is positive, meaning that it's in the, if it's positive, that means it's in this quadrant over here and that quadrant. If it's negative, then we know it's in that quadrant and this quadrant over there. I'll just write it neatly and show you. We are at the end of our lesson. But yeah, this is for negative hyperbolas. There is stuff on the quadratic function, but unfortunately we have run out of time. The quadratic function or the parabola is a bit more straightforward, but for the moment, because we have run out of time, I would like to just take a few more questions in the chat, and then we'll see from there. Yeah. So please post any questions you have for me. Are we all clear on this topic? If not, please send any questions that you have. So the 2 that you got, did it appear? I'm not too sure. So could you let us copy to do on our own? Sure. So I'll go back to it now so you can copy. So saying I should apply to teach at Grimsla. So I don't have a degree in teaching. I'm pretty sure your teachers are way more qualified. The equation of symmetry, please, for the hyperbola graph that we did. Just hold on. I just want to see if there are any other questions. What is the difference between the 3 graphs? Pilani, what graphs are you referring to? I do hope that this session has proved to be quite useful for you guys and that you guys continue to prepare for your exams. Good luck to everyone, and I'm really hoping that you ace the exams and do well. Remember guys, maths is all about practice. Practice makes perfect. And so the more you practice, the better you'll be. In the same way that I didn't start out knowing how to do math, all it took was a lot of practice. Baba Zila is asking, how do we sketch without knowing the values? Well, you need to know the values to draw an exact sketch, right? But you can at least know what the function may look like based off the equation. And this is where your knowledge on just the general form of a function is called upon. In the same way that you have to know when it's shifted left or right, you also have to know when it's shifted up and down. And in that way, you can already imagine what it would look like before solving for all the necessary information. I hope that cleared everything for you, Baba Zila. So please be with us, helping us each day with your YouTube handle. My YouTube handle is The Learning Space. Please, please, please subscribe. You will see me there along with the rest of the amazing team. I am a tutor at The Learning Space as well. And so if you go to the website, you'll be able to see more on the team and what we do. But our mission is to just help you guys as much as we can, because we do want to see you guys excel. Thank you very much, guys. It's been a pleasure. Can we do analytic geometry tomorrow? Yes, that is the plan. Tomorrow we are doing paper 2. Hopefully we do work at a good pace. But yeah, what we didn't manage to cover was the quadratic functions. And so for that, please go find the videos on our YouTube channel, The Learning Space. Everything there will help you out.